Hey everyone, how's it going? My name is SeanHodgins and welcome back to my channel. So I'm actually working on a really important project right now that needs to be done by the end of the month, but I'm currently waiting on parts, so I can't do anything with it. So today I'm actually going to be making a really simple project to increase my productivity and just a little cool device. Since I have some of these little gaming buttons, I have 5 of them, I'm just going to be making a shortcut tool, like a little button thing on my desk that'll run shortcuts on my computer. And I'm going to be using the Adafruit Trinket M0. Really simple project, so you should be able to build it pretty easily. I don't know what I'm going to build it out of yet. I might 3D print it, I might build it out of wood or acrylic, I don't know. I'm going to go check out my shop, see what I have, see what the best option is. Maybe I'll make a 3D printed thing and another enclosure. We'll see. Anyways, let's get to it. Okay, so I've got the body assembled together now. What I did was I took some 1/4" acrylic that I had laying around, and it's really great stuff to work with. I just chopped it up into different sizes, which I will provide a little template so you can copy it if that's how you want to do it. And then I used some acrylic glue to glue it together. And it's not perfect, but I threw it together just showing you don't have to have like a laser cut or something to work with acrylic. I also created a 3D printable file that is 3D printing right now, but it's going to take a really long time, and this is kind of like a one-day build. But if you have a 3D printer, then you can 3D print the body, and it actually uses a acrylic faceplate that you can cut out or laser cut out. I'll probably just cut it out myself. I'll show you that at the end. But all I have to do is throw these buttons in and solder some wires together and throw the trinket in, because I also 3D printed a little base plate for it so I can double-sided tape it to the inside of the acrylic base, just so it's not like on the electronic components. Anyways, let's get that stuff in and then I will program it. Let's go. So I just got that assembled and wired up and it's all ready to go, and then the 3D printed version actually just finished. And I wasn't sure if it was going to turn out properly, which is why I made that one, but now that it has and I know it will work, I might as well finish the project off with this one so you can see how they both look, since I showed how to assemble that one and build it as well. So you can kind of choose your design. If you have a 3D printer, you can do the 3D printed one, which is a lot easier, or if you don't and you have to do everything manually, you can do it that way. So I printed out a little template for the piece of acrylic in the front of the 3D printed version, and it'll let you know where to drill your holes and what size to cut the piece of acrylic to. Just kind of simplifies things. So I'm going to do that now and we'll finish off with that design. Let's go. Okay, all the wires are hooked up, so now I'm going to plug it in the computer, write a quick program, and then break down that program for you so you know how it works. The case turned out pretty nicely. It's a little bit short here. I'm not going to put it back on it, doesn't bother me, but I'll fix this file before I upload it so you'll never see this short file. But I think it's got a pretty cool look for how simple it is. It's got the shiny front. Of course you could 3D print the whole thing, but I decided to have this shiny fascia thing here. So yeah, it's all wired up, it's simple. And instead of putting spade connectors on and having those correct things that you're supposed to use on these on here, I just soldered on pin headers so that I could use the jumpers as I always use, so I can reuse those later. But I don't think I'll actually be taking this project apart because it seems like it'll be pretty useful. So let's head over to the computer. Okay, so I wrote a really quick program on this. It's incomplete because you need to fill in which hotkeys you want to use. Right now I've just got an example of doing Control-U to program an Arduino, and also I made my own hotkey, Control-Alt-N, which will open Notepad and then write Hello World. So that's kind of an example of what you can do. So I'll show you how this program works, and will take a few minutes. It's really simple, but you need to be using a microcontroller. I'm using the Trinket M0, but a microcontroller that is able to use the USB library, and that means it has USB built in to the microcontroller so that you can use it as a HID, a human input device. So this original program was one of the default Arduino programs called Keyboard Program, but actually it's changed so much it's really nothing like it anymore. We begin with this keyboard.h. So that is what allows you to have the Arduino pretend that it's a keyboard, basically. We use this to, instead of having to type key left control, I don't know, it was in the keyboard library, so I just stuck to that notation. So we've got the control key and the alt key, but you can look up other keys on the Arduino website. This doesn't have to be in this order, but these are the 5 buttons on the Trinket pins because there's 0, 1, 2, 3, and 4 I/O on the Trinket. So we're using all 5 of them, which is great. We're utilizing the entire little board. But select when you hit a button, that'll change that button number, and you'll see why that is. Again, a flag, that's when we know that button has been pushed to run the program that you want it to run. So we start the serial, and then we set all the buttons from 0 to 4 as internal, as an input, and a internal pull-up resistor so that they're always high when you're not pressing them. And that means they're connected low. And there's a schematic available if you want to see that, link down below. And then we attach an interrupt to this routine called butt pressed. So that means all these buttons are on an interrupt, so no matter where it is in the program you press it, it's going to go to that routine. So then we start the keyboard. That's just to initialize the keyboard and so that it becomes a HID device. HI device. And then so we have this loop, this while loop, that just keeps running if the flag is set to 0. So this flag is 0 at default, looping and waiting for a button to be pressed. Let's just say, so you don't actually see it here, but let's say I press one of the buttons. What happens is, it goes to this interrupt, butt pressed, and it sets the flag to 1 like we talked about, and then it looks through all 5 of the buttons to see which one you're pressing. It's just going to see that since you interrupted it, now you're probably pushing one of them because you're not fast enough to take your finger off because this is happening so fast, and it looks through all the buttons, sees which one is still low since you just pushed it, and it sets butt select to that value. So if you push butt 3, X is going to be 3, it's going to turn butt to select into 3, and then it's going to break out of this for loop and it's going to go back to where it was in the program. But now it's in the program, so it's inside this loop here. It's saying, oh wait, this flag is now 1, so let's not do this anymore. And then we use a switch case scenario here. So if but select is 0 for the first button, then it's going to run command 0. If it's 1, it's going to run command 1. Now you could put the commands right in here, but I did it this way so that it's broken right out of the program so it's easier to understand. It may not be, it doesn't matter. Do whatever you want, but I have subroutines called commands, so we'll go to those now. So command 0, this is my upload to Arduino, and we know that in Arduino if you do control U, it'll try to upload to something that's connected. So if button 0 actually does get pressed, then it's going to press control key and then U. So it stacks these up. It's holding them down. So whenever you do keyboard press, it's holding that button down digitally. It waits 100 milliseconds and then it releases all the buttons. You have to do that every time or else it'll just keep, it's like you just keep pushing down on the keyboard on different keys if you don't release them. So then we have command 1. And this is Control Alt N, that opens my Notepad++. Control key, Alt key, N, it's doing that. It's holding them down, and then it waits 100 milliseconds and it releases them. And then there's a delay of 500 milliseconds. And then command 2, I've just got hello world, and that is the print, keyboard print, so it'll actually just pretend it's printing that on the keyboard. So whatever thing you're in, it's going to show up if it's a text editor, and it allows characters to show up there. So you run through that. It runs whatever command you have selected for each case, for each button. Just remember buttons 0 to 4. And then it sets the flag back to 0 so that it sits inside this loop. And that's it. It's really simple. It just keeps waiting for an interrupt, and once that flag gets called, then it runs whatever command you have pushed down. So theoretically it is programmed now, but I'm not sure which button does which. So I'm going to upload the program just once again to make sure everything's working, and then we'll hit one of the buttons. We've got the command window open, and we'll see what happens here. Press this button. So that's actually button 3. Did control U. It's button 4. Oh, opened Notepad++, and it wrote hello world. If I press it again, it won't open it again, but it'll write hello world again. I'm pushing this button, and it writes to it. It all depends on how you wire up your trinket. So there are so many possibilities on what you can do with this. The reason I did it was I was just going to have one button because I like to do all my programming on this computer, but for simplicity's sake I keep all of the Arduino libraries and everything for coding on my laptops because sometimes I'm working not here. So I can use an external editor on my computer, have the Arduino plugged into my laptop, and then I can just hit the button from my computer to tell my laptop to upload the new code that I've changed. And also, if you're like a streamer, or you like streaming on YouTube or Twitch or gaming, then you can have different OBS settings and you can have them hotkey on the buttons so that you can change your scene just with these buttons. And I may use that if I ever get back into streaming. My internet's too bad, as you know, as I've mentioned before. But really the possibilities are endless. So there you have it, another one-day build, and the project turned out really nice. I love the way it looks, and it's going to be on my desk for a long time. I'm going to put it to use for sure. And you know the deal, if you want to build your own, there's going to be instructables on it. The code is going to be on GitHub and Hackaday, and the files are going to be on there, the 3D printed files and the dimensions, all that stuff. You can use those to build your own. It's really simple. Just get a trinket and some buttons and throw it together. You don't have to do this style. You can just copy the code and go from there. Make your own. Make it out of wood. Do whatever. It's been a long day, and I can't wait for this next project to come out. I think you're gonna like it. It's a Kickstarter, and I've got to finish it before the end of January because it's a Make 100, just like last year. So everyone, you know the deal. Be good and have a good day.